Hello students. So now let's start with the problem number 2, which is based on the higher order differential equation when the right hand side is e to the power ax into some function of x. So here I have a right hand side which is a hyperbolic function. So here we are going to see how to convert that hyperbolic function into exponential function and then solve this problem by the method of e to the power ax into v. So here we have equation as d cube minus d square minus d plus 1 into y equal to hyperbolic cos x into sin x. Now guys, this is the linear differential equation with constant coefficient. So if you see the right hand side, it is hyperbolic cos x into sin x. But guys, let me tell you that we have not seen any type which is matching with this right hand side. So what we are going to do is, so here we are going to convert that hyperbolic cos x into the exponential function by using the Euler's formula, and then we are going to use the type e to the power ax into v. So let's see how to do that. So here this is the right hand side. So 1 upon 2 is a constant, will come outside. If we multiply this bracket with sin x, we will get e to the power x sin x plus e to the power minus x sin x. And guys, to find out the particular integral, if you see this form e to the power x sin x or e to the power minus sin x, it is matching with e to the power ax into v, where v is some function of x. So I'm going to use that method. So accordingly, we will first find out the complementary function. So for that, we'll find the auxiliary equation. So guys, this is the auxiliary equation, which is a cubic equation, and if we solve this, then we will get 3 roots of this auxiliary equation. Now to get the root, there are 2 methods. One is use calculator and one is use the synthetic division method. So here I am not going to use the calculator because you all know how to use it. I am going to use the synthetic division method, so that tomorrow if you don't have the calculator, still you can find out the roots by using the synthetic division. So here for that I'll write down the coefficients. So coefficient of d cube 1, then minus 1, and 1. Next, here we'll take the different roots. So guys, I always suggest to student take 1. If 1 is not matching, then take minus 1, then 2, minus 2. Accordingly, take 1 positive, 1 negative number till you get 0 over here. So let's start with 1. Now this process is, we have to multiply and add. So first of all, we'll copy this number as it is over here. Now we'll multiply. 1 into 1 is 1. We will add. We will get 1 and minus 1, that is 0. Again we'll multiply. 1 into 0 is 0. We will add. We'll get minus 1. We'll multiply. We'll get minus 1, and in the end we'll add and we will get 0. So guys, if you're getting 0 over here, it means your root is correct. So I got the first root as 1, but in bracket I'll write d minus 1. Then in the second bracket we'll write down the remaining number. So this is constant. I will multiply this 0 with d and this 1 with d square. So that will become 1 into d square, that is d square. This term is 0 and this is minus 1 equal to 0. So d square minus 1 is d minus 1 d plus 1. So guys, here we can say that one root is 1. From here we'll get plus 1 minus 1. So 1 and minus 1. So we got the 3 roots. Now guys, as we got the 3 roots, all 3 roots are real. So here what we are going to do is, we are going to find out the complementary function by using the rules which we have learned in the previous video. So if you don't know how to find a complementary function, you have to go back to that video where I've covered how to find out a complementary function for the given higher order differential equation. So the complementary function which is yc is c1 e to the power negative x, because minus 1 is a real root and which is non-repeated. Then we have next root as 1 which is repeated twice, so we'll get c2 plus c3x into e to the power x. So this is the value of complementary function. Now let's find out particular integral, which is equal to 1 upon function of d. So guys, here the function of d is d cube minus d square minus d plus 1 into right hand side. So this is the right hand side, so we'll write it. Now 1 by 2 is constant, we will take it outside, and we will apply this operator separately on first term as well as on the second term. So we'll get so now 1 by 2 as it is. Now guys, let's compare this form with our formula. So here this particular integral is 1 upon f of d e to the power x into v. So here we have v as sin x and e to the power x as e to the power x. So value of a is 1. So what do? We write that e to the power ax separately, and then we replace that d with d plus a. So since a is 1, we will replace d with d plus 1. So here we will get 1 upon now similar process will do on the second term. So here the value of a is minus 1, and that is why we'll replace d with d minus 1. So here we will get, now let's expand these brackets. So d plus 1 cube I'll expand by using the formula of a plus b the whole cube. This is a plus b the whole square and so on. And then we'll apply this operator on sine of x. So guys, here I'm going to use the rule of sine ax to get the answer. So let's expand it first. So here d plus 1 the whole cube will be, then d plus 1 square, but since we have negative sign outside, I will change the sign of all terms. So that will be next, here we'll get negative d, negative 1, and that minus 1 will cancel with this positive 1. So here we'll get minus d into sine of x. plus e to the power minus x. So guys, here we have only e to the power x, so 1x we can say, as it is given in the question. Next, I'll expand this. So I'll use the formula of d minus 1 the whole cube and d minus 1 the whole square over here. So that will give us next. This will be negative d, then positive 1 and 1 plus 1 2. So here minus d plus 2 into sine of x. Now let's simplify these terms. So here this 3d and this minus 2d is d and minus d, so all terms are cancelled. Now I'll write down the remaining terms. So that is 1 by 2 in bracket e to the power ax into 1 upon d cube, as it is. 3d square minus d square is plus 2d square. Then here 1 minus 1 again cancel, and the sine x term as it is. So it means we are going to apply this 1 upon d cube plus 2d square on sine of x. Similarly here, this is 2, minus 1 and minus 1 is minus 2, will be cancelled with this 2. Then we have d cube minus 3d square and minus d square is minus 4d square. Then 3d, 2d, 5d minus, that is 4d. So here plus e to the power minus x. So guys, here we have 1x. So into 1 upon now guys, here if you see the function, it is in the form of sine of ax. So whenever we have a function as sine of ax, that time we replace d square by minus a square. So here I'll replace the d square with minus 1. D cube I'll rewrite as d square into d. So here we will get half into e to the power x 1 upon, this is d square into d, where d square is minus 1. So minus 1 into d is minus d. Then this d square is minus 1. So minus 1 into 2 is minus 2 into sine of x plus e to the power minus x into 1 upon d cube is d square into d. So d square is minus 1. So minus 1 into d is minus d. Then this d square is minus 1. So minus 1 into minus 4 is plus 4 plus 4d into sine of x. Next, here we have minus d minus 2. I can take negative sign outside, we'll get d plus 2. But guys, how to solve this d plus 2, or how to operate this 1 upon d plus 2 on sine x? So there are two methods. One is use the inverse operator method, or rationalize this so that here you will get d square minus 4 and then you can get the answer. So here what I'll do is I'll rationalize this d plus 2 term. So that will become 1 upon 2 negative e to the power x. By rationalization, that d plus 2 will become d square minus 4, and here we will get d minus 2. So what I did is I have multiplied this d plus 2 with d minus 2 and here 1 with d minus 2. So that is the process of rationalization. Sine of x as it is. So sine of x. Next guys, here minus d and 4d will be 3d, so 3d plus 4, this is e to the power minus a as it is. Now to get the term or d square term in the denominator, we will again rationalize here. So now I'll rationalize it with 3 minus 4d. So I'll multiply with 3 minus 4d numerator and denominator. So I'll multiply and divide with 4 minus 3d. So 4 minus 3d in the denominator and 4 minus 3d in the numerator. So that will become 16 minus 9d square in the denominator. So here right now we have 4 plus 3d. So I will rationalize it, and that is why I'll multiply and divide with 4 minus 3d. So guys, e to the power minus x as it is. So 4 minus 3d upon 16 minus 9d square into sine of x. So by doing this, we got d square term in the denominator, and now we'll replace d square with minus a square. A is 1, so minus a square is minus 1, so d square is minus 1. So we will get 1 by 2 minus e to the power x. This is minus 1 and minus 4 will be minus 5. Then we have d minus 2 into sine x plus e to the power minus x. D square is minus 1, so 16, and this is plus 9 will be 25, so upon 25, and 4 minus 3d into sine of x. Now 1 by 2 as it is, negative sign will go, so we'll get e to the power x by 5. Now we'll multiply this bracket d minus 2 with sin x. So d of sin x is nothing but derivative of sin x, which is cos x, and this is minus 2 sin x as it is. This will become plus e to the power minus x upon 25. 4 into sin x, that is 4 sin x, and this is derivative of sin x is cos x, so negative 3 cos of x. So guys, if you want, you can simplify these terms, or you can keep this particular integral as it is. So this is the value of my particular integral, and we also got the value of complementary function. So the last step is we have to write down the complete solution or the final solution, which is addition of complementary function with particular integral. So guys, you can copy down these two values here, and you will get the final value or the final answer of this higher order differential equation. So I am sure that you understood how I've applied the method and how I got the solution of this given higher order differential equation. So guys, keep watching the videos on Ekeeda.com, because this is the only place where you can get all engineering subject under one roof. Thank you very much.